Load balancing, we are going to do unequal cost path. Okay, for that, we use a parameter called variance. So variance is nothing but feasible successors FD. Okay. FD divided by successor roots. Successor. Okay, this is the formula. So when you give a show IP route, you will see multiple routes and its feasible distance and reported distance. So you can get that value from the output of show IP route. Okay, after you run the EIGRP process. From that output, you will get the FT distance for the feasible successor and the successor route. You divide it both. Okay, you divide that value, and say feasible successor is, for example, 5376 divided by 3328. Okay, you will get one value of like 1.6. You round off that to 2. Okay. Once again. Okay, we are going to just round it off to 2. So here, let me put up a diagram. So for that, like you'll be able to understand it better.
I think you're on mute.
Yeah, sorry. So in order to reach R1 to this destination, 10.4 network, this will be the successor route and this will be the feasible successor. So why it is selected as successor here is, though R1 is having one hop here from R1 to R3, then R4, the cost here, for the link cost here, the metric calculated is 256. So from R1 to R3 is 256 and R3 to R4 is 256. So total it is 512, right? When compared to the metric from R4 to R1, it is 2560. Okay, so the metric here is higher value, even though if there is no routers in between, the metric is having a higher value. So that has been elected as feasible successor. Right. So now the feasible successor is not going to hold any traffic. So we want to load balance some of the traffic, network traffic to this route as well. For that, we are going to use a variance component. Okay. How the variance is calculated is, like I said, in the show IP route output command, you will get to know the destination. For this destination, which is the router, which is the next stop IP, you will receive. From there, you can get the FD distance. Say, yeah, if you see here, for this route, we have one successor, FD3328. Likewise, via 2 paths, you can reach to this network. And those are the FD and RD. FD feasible distance, RD is reported distance. So this is the feasible successor, 5376, and this is the FD of the successor route. So 5376 divided by 332. This is manual, okay? Calculating the metric and by its own selecting the successor feasible is automatic by itself, EIGRP is doing. But in order to load balance the traffic is manual part. We have to do it. A network administrator have to manually calculate this variance value and load balance. Okay. Okay, so that is the calculation I've mentioned in the text file as after dividing it comes to 1.6. Okay, and that 1.6 is rounded off to 2, number 2. Okay, so now what we are going to do is okay. So this multiplier is going to be a whole number, not on decimal values. Okay. And what we are going to do is we are going to divide in order to get the variance multiplier. So after dividing, we are getting a value of 2. Okay. So this 2, how we are going to use? So in the route, in the just router's configuration mode, okay, we are configuring EIGRP, right? And EIGRP should have an autonomous system number, which is nothing but 1265355 value. Okay, within this range, any number can be used. Okay, so I'm using EIGRP 1 and network. Network is the command. Network is the command to define all the networks which are connected to that specific router, not on the neighbor's router. It's just going to advertise its own information only. Okay. Say, for example, 172.16.1.0. If you're going to leave the subnet mask or wildcard mask blank, it's going to just use the default value, right? So if we have a specific subnet mask to be defined, then we need to define it. So let's consider it as a class C range. So 0.0.0.255. This is the subnet mask, wildcard mask, right? We are mentioning all the network bits as 0 and host bits as 255. Okay, so if we are going to leave this part blank, okay, the subnet mask part blank, then it's going to consider the default subnet mask for class B, 255, 255, 255, sorry, 255, 255, 0.0. So in order to not to use the default value, we have any specific prefix mentioned, then we need to define it in this way. It's actually the reverse way. This we called it as wildcard mask. All the networks bits at 0 and the host bits as 1s. Likewise, we need to declare. Then we have a variance, right? So variance is value 2. That's it. This is the configuration we are going to do in the router. So automatically what is going to happen is it is going to load balance the traffic to the backup route as well. So let me put up a similar output, okay, which uses with the variance multiplier. Okay, I'm sharing it in the WordPad. So you're able to see my screen, right? So
Yes,
this
ma'am.
is how the output will look like. Show IP route for this destination. You will see 2 routes. Earlier, it was not like that. Earlier, 2 routes will be, I showed you, right, how the FD, to check the FD value. In that output, it will not be like this. Here, it would say route metric is 5732. So 5732 is nothing but the feasible successors path. There, the traffic count is 144, means that much of traffic or network traffic has been sent. And to the other part, that is to the successor path 3328, FD distance, this much of traffic count is sent. So this proves both the, on both the links, the traffic has been sending and receiving. This is after the variance multiplier is configured in the EIGRP process. So this is how we load balance. If at all, if there's a requirement to load balance, then we can share traffic between 2 links. If it is not required, then we can just leave as it is. The feasible successor will be just idle only. There will not be any traffic sent on the feasible successor's path. Okay. Clear on this unequal cost load balancing?
Yes, ma'am.
Okay. So we'll move on to the next one. Next topic on EIGRP
I
is the
think
route summarization.
I have one doubt.
Yeah.
After entering autonomous number and network ID, we need to also enter router ID, right? In the configuration.
Router is not required. No.
Router ID. Is it in EIGRP or OSPF? You're on mute.
Yeah, I'm on mute. Yes, tell me. Router ID, you're talking about the router ID, because router ID will, configuration will something come in the OSPF process.
Okay. It's like very similar. So that's why. Okay, got it. Yeah, go ahead with the next topic.
Yeah, 1 second, 1 second. Okay, sorry for that. So yeah, let's so this is just a configuration about the variance. Let me share the screen. Okay. Now let's go to another topic, route summarization. Okay, route summarization is so by the word itself, it means that we are going to summarize the network prefix. So why we are going to do it is, see, EIGRP, EIGRP is actually like as an additional feature of route summarization, where the size of the network is getting reduced in order to increase the convergence. Okay. So say for example, we are having 3 routes, okay, 3 routes to reach the same destination. Instead of sending 3 different network prefix routes, we are going to send it as one. If at all, only summarization is possible. If all the 3 networks belongs to different classes or different like one is belongs to class A, one belongs to class C, then summarization cannot happen. But if at all, if all belongs to the same class and also like within the range, okay, 1 dot or 2 dot or 3 dot, different ranges or in a sequential way, then we can do a summarization of the route. So summarizes the network prefix on the interface level. So we are going to apply the summarization on the interface, LAN interface, not on the router EIGRP process. Okay, we are going to summarize at the interface level. An aggregated summary of the IP addresses we are going to apply on the interface level. Okay, why we want to go for a summary route? That is the question. You can ask me, I can just send the traffic just like that. However, how I'm going to advertise my network in a normal way, I can send it in the similar way, right? Why should I use a summary? Why should I summarize the routes? Then, because for the summary route, we have a different AD value, right? So what is AD? Administrative distance. So for each routing protocol, we have a different AD values, correct? So for EIGRP, what is the administrative distance beeps of? 90, right? For EIGRP, it is 90. Okay. And for EIGRP summary route, we are having an AD value of 5. Okay. It's just only 5. So that means the administrative distance for that is 5, meaning the trustworthy of the routing protocol is very high. We can rely on the route or we rely on that protocol. So administrator will choose a summary route instead of normal route whenever or wherever it is possible for them to do it. Okay. So now what is this? Okay, so how are we going to configure a summary route? Okay, I'll put up one diagram over here. This is the network which I'm going to advertise. So R1, R2, R3, R4 are the 4 routers. If you see what are the network behind R1 is 172.116, 1.0/24. This is 12.24, this is 23. So same, it's 172.16.3 and 16.24. So if you see all the networks in this EIGRP process comes under 172.16 range only, not beyond that. Okay, so what is the best way to summarize is, what is the best network we use is 172.16.0.0/16, right? So 1, 3, 12, 23, 24 all comes under this range only. So it's better, instead of using /24 networks, one for each router, I will put as /16, okay, or on this R2 router, so that this entire route will be sent or advertised to R4, like 172.16.0.0/16. Not these specific routes will be seen. Okay, and this will be as a summary route with the AD value of 5. Okay, that is configured on the R2 router. This is how we are going to summarize the network. Okay, so I'll give another example, a simple example. Okay. Okay, this is again a simple example for route summarization. So router 1, router 2, on these two interfaces, I'm using 10.00 range /24. Here I'm using 172, 168, 1.1 and 2.1 series. And here I'm having only one network to be advertised. So how I am going to configure the summary route is what we are going to see here. So first, what I have to do, so this is, I'm just, with this, I'm going to just share the basic commands to enable EIGRP. Okay. Right. So first, let's go to router 0. Router, so we'll call it as router 1, not router 0. Okay, router 1 and router 2. Okay. So on this global configuration mode, interface fast Ethernet 0/0, I'm going to enter IP address 10.0.0.1. Just I'm applying interface IP address, right? This is the WAN interface going to connect to another router. So I'm going to apply this IP address command and just a no shift to be on safer side. I can give it at any time. Okay. Next, this is on the R1 router. Okay. On the R1 router, what are the other configurations I can do? Yes, I have to configure these loopback IP as well. So interface loopback 0. Loopback is just a logical interface. Logical interface where you can create it anytime. It need not used for routing purpose, but for checking the reachability of the router. See, physical interface, if it is gone down, that means the cable must be faulty or port faulty, something faulty, the physical interface is not reachable. I cannot reach the router through this interface. I cannot ping the router. I want to know if the physical hardware is up or down. Okay. For that, what I will do, I will create a logical interface, a loopback interface, a configure with an IP address. Okay, so that even if the interfaces are down, still remotely I'll be able to ping the loopback IP to check if the router is live or not. For that purpose, I can use the loopback interface, and there are a few other purposes you'll come to know when to use a loopback or IP address, where and all. But this is the basic purpose of a loopback, to check a logical interface created, just to check the reachability when the other physical interfaces of the router is not functioning or down. Okay. So here, this is just for, what to say, we are just doing some commands check only, right? For that, I'm not using a physical interface. I'm using the logical interface itself. IP space address. So what is the address? 172.168.1.1. Okay. And what is the network range? 255 dot /32 means 255. Okay. And then another interface. This is all on router 1. Loop back 1. IP space address 172.168.2.1. So this means this is the only active IP address in this range. That means we are making the subnet mask as 255. Means this is the only alive IP in this range. Okay. Okay, we are done with R1 router. R2 now.
Can you mention what is loopback means? I did not
Loopback
understand.
is the logical interface.
Okay.
This is the logical interface which we are, which can be configured in the router for testing purpose actually.
What does it test?
What is the?
What does it test?
For testing the, this is for testing means it is not going to test anything on the router, but as an administrator, we are going to use this interface for our own testing purpose. We are going to use it for testing not on the real-time network. On the real-time routing in an organization, or you want to route any network on EIGRP or OSPF anything, we are not going to use this IP address because this is a logical IP. This is not connected to any PC, or there is no cable connected on this interface, or there's no physical connectivity at all. This is just an IP address for a logical interface assigned to check the router's reachability. Okay, like I said, the router might have one fast Ethernet, one gigabit Ethernet, one serial interface, any number of ports. But all the ports should be assigned with an IP address and should have a cable connected. Okay, cable connected either to a switch or to a remote router. Okay, and we need to assign IP and routing to be done. Only then only then like a complete configuration is done. Okay, say if this fast Ethernet port is down, being a network administrator, what I will think, how will I check that fast Ethernet is down? I will try to ping the IP address, whatever is assigned to the fast Ethernet port. I know the IP address by the topology diagram. So I know what is the IP. I'm going to ping it remotely from my machine, from my laptop or from my office desktop, somewhere remotely I'm pinging it. If I ping and see, it should get reply means, okay, this router is live. Yes, I can log into this router remotely. Okay, remotely I'll log into the router, do the configuration and all. But that's how a network administrator do. He will have access to all the routers and switches in that specific organization, and he will log in remotely only through a remote desktop. From there, he will use a putty terminal and then he will access it. At that time, when he pings 10.0.0.1, it is not reachable. Does it mean that router is down? No, right? Router hardware is not down. Physically, router is powered down only. It is not down. But how I will check if the router is powered down or completely there's something wrong with the router, or if the router is located in some office, how do I know if that office itself is down, or is it having some power issue or power maintenance, power shutdown? How will I come to know? I should know, right? If the router is on, only if the router is online, only if there's some network connectivity is there in that office. If the router is powered off due to a power shutdown or due to power fluctuation, if the router is damaged, then the office itself is down. Okay. But by pinging this 10.0.0.1 IP, if I'm not getting a reply to the ping request, does it mean the router is down? No. That interface can be down. I need to verify if that interface alone is down or the entire router is down. How will I verify? For that, I will configure one more interface, a logical interface, a loopback interface with an IP address. So with that IP, I will ping and check if the router is live or not. If the when I ping to the loopback IP, if I'm getting a response, then I can come to a conclusion it's just only the interface is down. Still, I'll be able to log into the router through the loopback interface IP. I'll log in and I'll check, okay, why the interface is down. Is it only fast Ethernet or the serial or some other interfaces is also down along with that? How to troubleshoot? I'll call upon the local technician, whoever is available there, IT technician, check the physical connectivity, and I'll proceed with the troubleshooting. For that purpose only, loopback interfaces are configured. Okay, this is not a physical interface. You will not be able to see the interface in the router hardware. A logical interface used for testing purpose. But since when you want to use a simulator and all, in that you can configure loopback and see. Just a loopback interface, you can use it for your routing and all. Okay. So next, similar, we need to configure on the R2 router as well. Interface FA 0/0. I need to put an IP address, IP space address. And its IP address is 8.8.8.8. 255. So with this, my interface configuration is done. I'm just configured only the interfaces. I have not enabled routing between these two routers. So now I need to do the routing. So on both the routers, okay, let's enable routing. Again, so all the commands starts with the router configuration mode only. Okay. So now router EIGRP. So router EIGRP autonomous system 1. Next, I need to, this I'm entering in the R1 router. Okay. So R1 router, how many networks it has, how many IP addresses, interfaces it has, this network, this network, this network. So 3 networks are there in R1 router. So network 10.0.0.0, 0.0.0.255. Next, network 172.168.1.1, 0.0.0.0. Network 172.168.2.1, 0.0.0.0. Right? So with this, I'm telling my EIGRP process to advertise these 3 networks via this router. So this router is going to advertise these 3 are the network I have, so that any directly connected neighbor router can update in their routing table, right? On the R2, similarly, what we are going to do is router EIGRP 1. Same autonomous number should be given on the R2 router to establish neighborship. So we have seen certain criteria, right, to form neighborship. Neighborship, in order to form neighborship between the routers, the AS number should be the same. Authentication, K value, subnet and all should be same. So first thing is AS number should be same. Okay. So EIGRP 1. So what are the networks this R2 is having? This network and this network are the directly connected networks. Anyways, the router is going to advertise its own network only. It's not going to advertise any of the other neighbors' network and all. It is least bothered. It's just going to advertise its own network, and then it is going to get updated in the routing table. Okay, let this R2 router first advertise its network. Network. What is the IP address? 8.8.8.8, 0.0.0. Another network, 10.0.0.0, 0.0.0.255. Okay, that's it. So routing is enabled. With this, EIGRP process is running on both the routers, and both have formed the neighborship, and they are started to exchange routing information. Now, how to configure the summary route? Because I have two similar network IP ranges, okay, to advertise to this router, but instead of sending two different network prefix, I'm going to send it as one. For that, what I'm going to do is, so I'm going to use the interface, the router from here only, because from this router only, these two networks are connected. So on the R1 router, let me go to the LAN interface of the router. LAN interface of the router is where the switch is getting connected. Okay. The LAN interface of the router is where the switch is getting connected. Here I'm using this interface, FA0, but I'm telling, okay, but I'm telling on the LAN interface. The router will have a WAN interface and a LAN interface. WAN interface is where it is getting connected to, it's to the remote router. On the LAN interface, it is getting connected to the, sorry, I mentioned it wrongly. So this summary route should be added on the WAN interface of the router only. Sorry. Okay. Summary route should be added on the WAN interface of the router only, not on the LAN. Okay, by mistake, I mentioned it wrongly. So WAN interface is the interface where the router is connected to the neighbor router directly. LAN interface is the interface where the router is getting connected to the switch. So that is here in this diagram, it is the loopback interfaces. That is the LAN interface. So here on the WAN interface, I'm going to add a command IP summary-route EIGRP1. I need to mention the EIGRP process. And then 172.168 dot, sorry, so 172.168 dot 0.0 255.255.252. So this is how a summary route I will mention, because the network bits are getting changed over here. So over here it is same, over here it is same. Only here it is getting changed, right? And for that, I need to check what is the subnet mask. When I calculated it, the subnet mask is 252. So this will be the summary route. So this route, how it will be seen in this router is like 172.168.0.0 slash 252 is how much? What is the value for 252? 23. This is how it will be seen. This is with subnetting. If you know subnetting, then this is easy actually. See, you're still not clear with this subnetting part, right?
I'm clear. I know subnetting. Just that calculation I need to do
Yeah,
fastly. That's it.
faster we need to do. Let's see.
Actually, I did not understand that summary part. IP summary. What are you doing there?
Summary. I am summarizing these two network as one single network. Okay, see.
So why it is 23?
Yeah, that's what when we do subnetting only we'll understand. 172, 168, 1 dot range, right? 1.1 is one network. 172, 168, 2.1 is the network, right? So network bits are same. Okay, 172, 168. So here only it is getting changed. So I need to add these two networks as a single route means I'm just putting in this format, decimal format. Sorry, binary 0, 0, 0, 0, 0, 0, 1, right? So let's make it a 0. I'm just putting this decimal value, this third octet into binary. Okay. Same if I'm going to put the second IP also. 2, 0, 0, 1, 0. Got it? Somewhat understanding for you now?
Yeah, this part I know.
Okay. So 192, 160, this is what has been split up. So now the network bits till here are same, right? Till here it is same, correct? So till here all are network bits only. Okay, here only the value is getting changed. So for this, how will I calculate the subnet mask? So what will be the 255, 255, right? Network bits, all 255s. Okay, here network bits. How many network bits are there? 1, 2, 3, 4. Host bits. And these are all host only, dot 0. So what will be the value for your all ones? What is the value? Can you calculate? One 128, right? 128 plus 92. Plus 16. You got it? You're getting, because I'm just teaching in the middle of the subnetting, so I'm not sure how to.
223.
223 or 224 will come.
24. Okay. Yeah, I'm understanding. It's very simple only. Just
Yeah. So this is how you will do subnetting or summarizing. So this is the subnet mask, and you can just mention for which network. 172, 168, 0.0. Okay, this is how you can mention when you go for a summary route. But in this example,
okay, it is class B, right? It is class B,
yeah,
so
class
network,
B.
host,
Yeah.
host. Okay.
So
All
class
host
B,
bits turn to network bits.
Yeah,
That's why those zeros are ones.
yeah, right.
Okay, got it.
So in this network, it's only the third octet was keep on changing. 1, 3, 23, 12, 24. So
So
only third,
network address will be 0.0.
right.
Got it.
Okay, so for this, the summary route is this. So summary route is also like uh, it is not by default, it is not sending as a summary route. Only if the network administrator wishes to advertise those networks as a summary route, only then is doing based
Yeah,
on the
usually we
requirement.
don't do it, right? Yeah.
Yeah, mostly we won't do it. Just by default, we will advertise on the EIGRP process under networks. That's it.
Because we need to manually calculate all these things.
Yeah, manual work is there. So we do not do it. So with this EIGRP is over here. Actually, when comparing to OSPF, BGP and all, EIGRP is very simple concepts and simple to configure.
Yeah, even OSPF is simple. Maybe BGP stuff like this.
BGP, but OSPF has many things like that's packets, LSAs,
Yeah,
areas.
yeah,
So
yeah.
concept wise, OSPF and BGP is having a huge contents are more actually there. Yeah, yeah. Thank you.
Yeah.
Yeah.